everyone, welcome to this webinar. I'm Cindy. Today in this webinar, I'm very excited to introduce you the new features and major improvements in our soon-to-be released AttributeStudio 8.6 version. And the official release for 8.6 will be soon available after this webinar. Same as the previous webinars, in this webinar, I will give live demo for the functions I highlight today. But before the live demo in the software, let's have an overview about what's new in AttributeStudio 8.6. In this webinar, I will talk about these 12 new features and improvements. Other than these 12 features, we also have many other usability improvements and defect repairs, which I will not have time to demo today. But those will be summarized in a separate PowerPoint, and it will be available to our clients to download along with the official release of AttributeStudio 8.6. So among the highlights, the first two new functions aim to improve the usability. We've added a dynamic well information window in 8.6 for users to quickly access the well information for different wells. The second is we've added a command to quick access to a seismic section intersecting with a well. These two new features will ensure that they will help users to improve the efficiency when they navigate the software. The third feature we added is to merge separated well logs into one log. In 8.6, we improved fault likelihood attribute, which becomes much simpler and easy to use for users. We also improved our synthetic traces and well type for 2D and deviated wells. The first 5 points are about the new feature and improvements on our basic functions. In 8.6, we've also done several new features and improvements on our in-stage 4D microseismic and microseismic related functions. For example, we add new controls to generate and visualize in-stage 4D microseismic volumes. You can also calculate drill bodies and SRVs from in-stage 4D microseismic volumes and build deep learning models for predicting SRV from completion data. We've also implemented making 3D volumes from microseismic events and added a workflow to predict microseismic event density from seismic attributes. Besides, a new window to visualize multiple completion data has been added. I will firstly spend some time on the first 5 basic functions and then spend most of the remaining time to demo these microseismic related workflows. The last important change is that in 8.6, we changed to a new geographic projection toolkit and improve the user interface. I will demo this in the software as well. Now let's see the details for each new feature and improvements. The first is the dynamic well information window. Before, it's very time-consuming to access the well information through the red button menu from the tree view. Users have to open a separate properties page or spreadsheet for each well to check the well information. Since 8.6, we've added a well information window to dynamically show the well information as users click the well on tree view or in the visualization windows. The well information window can be enabled if you check it in the view in the top main menu, and it will be at the bottom left position in default. It has 3 tab pages summarize the general information, well tops, and well logs. This is a dockable window, so you can move it to any well you want, for example, to the bottom, or putting it back to the bottom left. When you click on different wells on the tree view, you can see the well information changes in the well information window. It also works in visualization windows. When you click on different wells on base map, and you can see the well information updates accordingly in the well information window. The well is also highlighted on the well section as the well section and base map are synchronized. You can also click on different wells on well section, and the well information will update in the well information window. The same well is highlighted on the base map. Also, you can click different wells on the seismic section, and the well information updates in the well information window. It also works in 3D window. When you click different wells in 3D window, you can see the well information changes in the well information window. To hide this window, you just go to top main menu, view, and uncheck well information. To enable it again, you just check it back. So we believe this quick and easy to access function can help users to improve efficiency. The second feature is also a usability related function. We add a quick access to a seismic section intersecting with a well. Before, in a seismic section window, if you want to move to a section intersecting with a specific well, you need to open a base map window and display the well and the seismic section position on base map, and move the section by monitoring it on the base map to see when the line intersects with the well. This process is very time-consuming and not easy to navigate. Now we add this switch seismic to the well command, which would quickly and accurately reach the purpose. When you are in a seismic section window and display the inline or crossline on the well data tree view, you can right-click on the well which you want the section to move to and select Switch Seismic to this well. The section will quickly move to the well you select, as you can see on both seismic section and base map, which could help users improve the efficiency when navigating the software. The next feature I want to demo is merge separated well logs into one log, and I will demo this function in the software directly. As you can see here, for this well, I have two gamma ray log. One of the range is from here to here, and the other gamma ray log range is from here to here. And what I want to do is I want to merge these two gamma ray log into one gamma ray log to have the full range from here to here. So what I can do is from the tree view, right-click on one of the gamma ray log and then select Merge To. And then this is the current log curve. And you can select another log curve to merge on the tree view and use this blue arrow to select that. And this is the merge log curve name, which you can edit. And in the overlapped segment, you can set which log to be taken the value from using this drop-down menu. And this checkbox take valid value as priority. If this is checked, then in the overlapped segment, if the value of one selected log is invalid and another log is valid, the valid value will be used. Then you can click OK to generate the merged log. And this is the results here. You can see this merge log, merge these two log into one log. So this function is useful when you have separated log and want to merge them into one log. So one of the major improvements we've done in 8.6 is that we improved fault likelihood attribute. As you can see, the fault likelihood result in 8.6 has less artifacts compared with the result in 8.5. Before, it has these net-shaped artifacts, which may not indicate the real faults. In 8.6, those artifacts have been removed, and you can also see the faults becomes much more smoother than before. And the user interface also changes. In the new user interface, you only need to set the threshold and window size for the fault likelihood. Larger threshold will have more faults retained. Basically, there will be only one fault likelihood result generated instead of several results as in the previous version, which would be easier to understand for our users. The next improvement I want to highlight in this webinar is that we improved the synthetic traces and well type functions for 2D and deviated wells. And I will demo this directly in the software. So here I use this well as an example. Since 8.6, we extract the seismic traces along the well path and render it as the right traces, which is here, and this is the new object on the tree node in synthetic folder, as you can see here. And if you open an 8.5 project in 8.6, it will generate this seismic trace automatically. And you can compare it with the blue traces, which is the synthetics. So the seismic well tie is now between the blue traces and the red traces, which becomes much easier for users to tie the well. And the synthetic blue trace is drawn along the well path on the original seismic trace, which is better to see and QC the well type. And we also add a new command, create seismic random line from extracted seismic trace. So start from here, if you right click, you can create a seismic random line along this wellbore. So this is the random section line that this command created. And this random section is saved under the seismic survey. And you can see it by right-clicking and select Show in Section window. So this is the random section I created. And then you can compare this random section with this original seismic traces on the well section. So basically, they will be the same. So this is a way to QC the extracted seismic traces. And also on this seismic section, you can see the synthetic is drawn along the well path. And this would help you if you want to do the seismic well tie on a seismic section. So we believe all these functions will help improve the accuracy of well tie for deviated wells. We also improve the render of well and well tops on the extracted seismic trace and the performance of well ties. For example, there will be no stack, and it becomes smoother for well ties for multiple wells at the same time. And we also add support the smooth function for the synthetics extracted traces along the well path and the extracted seismic traces. So if you want to change its smooth factor, you can double click on one of the traces. And in the visualization, you can change the smooth factor. We also support editing the display data range for synthetics for these three traces. So if you go to the color map, you can change the display range by dragging the line on the color map. So you can see this display range changes accordingly. We also support 2D well type now. The 2D well type process is the same as 3D well type process. The only difference is that instead of using a 3D seismic survey to extract the seismic traces when generating the synthetics, here we use 2D seismic line. An important change about well TD curves in 8.6 is that we support well TD curves for multiple seismic surveys. So now every TD belongs to one specific survey, and there can be multiple TDs in one survey, but only one active TD for one survey. For different surveys in seismic section, the wells are projected using their own survey's active TD. When displaying well and well log TWT in 3D and well section window, it uses the active TD in the first survey. You can also share the TD by setting friend survey for other surveys. For example, if there is no TD belongs to seismic 4, you can set its friend survey as other surveys. For example, seismic 1 to use seismic 1's TD as its TD. And this function is available among 2D and 3D seismic surveys so that the TD can be shared for different surveys. So far, I've introduced the first 5 features and improvements in the basic module in 8.6. Now I want to highlight some new features and improvements on the microseismic related functions. The first is the new controls to generate and visualize in-stage 4D microseismic volumes. So the in-stage 4D microseismic volume generation and visualization is a big module in AttributeStudio. If you are not familiar with this module, this is a new method of generating 4D microseismic volumes to analyze the microseismic development process with a small time interval, for example, 10 minutes within each fracking stage. The 4D microseismic volume data can be animated and visualized with pump pressure data, fracking stages, and perforation clusters in our dedicated 4D microseismic window. The new controls we've added in generation and visualization of in-stage 4D microseismic volumes include 3 aspects. The first is that now in the 4D microseismic volume generation user interface, user can define the stage number for the accumulation begin stage. And this function only works for the accumulative 4D microseismic volume generated across stages. If you remember, when we generate 4D microseismic volume from microseismic events, it can generate the event density each interval, accumulative event density inside one stage, and accumulative event density across stages. So this feature is added for the accumulative event density across stages. Before, the accumulative event density across stages always start from the first stage, and this may not be what users expect because sometimes we want to aggregate a subset of stages and only see the accumulative event density within these stages. For example, if we only want to see the accumulative event density across stages from stage 5 to stage 10, we can check stage 5 to 10 and define the accumulation begin stage to 5, so that the accumulative event density will start from stage 5 instead of stage 1. This adds the flexibility for users to analyze the 4D microseismic volumes in a subset of stages. Also, in this interface, we add an option to let users select an existing 3D survey to constrain the 4D microseismic survey geometry. If any 3D survey is selected, the generated 4D microseismic survey geometry would be the same as the 3D survey's geometry. This would be useful when users want to analyze the 4D microseismic volume with the 3D seismic volume. The second new control in 4D microseismic volume visualization is that now in our 4D microseismic volume window, users can overlay other wells 4D microseismic volume on the base map view when playing the active 4D microseismic volume of the current well. Let's see this function in the software. So here I have a microseismic project, and as you can see, I opened a 4D microseismic window and displayed one 4D microseismic volume. So in this 4D microseismic volume, I can see the base map view, the profile gun barrel view of the 4D microseismic volume. And at the bottom, this is the time histogram, which you can change to different intervals within the stage. In this case, it's stage 5. So as you can see, when I change the time interval, the 4D microseismic volume changes. And so this is the current active 4D microseismic volume. And this well is the current active well. And on this base map, you can see I also display the other wells information, including the well path, stages, and microseismic events. So to overlay the other 4D microseismic volume, you can select this button here. And in this dialog, you can select another wells 4D microseismic volume to overlay on this base map. So for example, I can choose for well B, which is this well besides the current active well. And let me select an event density in the same stage, which is stage 5. And you can see this is the results. You can change different event density to overlay on this base map. And when you overlay this 4D microseismic volume on the base map, you can still use this time histogram to change to different intervals for this active 4D microseismic volume. So you can see the overlaid volume will be static and transparent, while the current active 4D microseismic volume will be solid in solid color. So this function could be useful because when you analyze the current active 4D microseismic volume, you may want to see how the other 4D microseismic volume look like and try to find a relationship between them. The other improvement in 4D microseismic volume visualization is that now the animation of a cumulative event density across stages 4D microseismic volume will play across stages from the first stage to the last stage. Before, it only plays the animation within each stage, which may not be useful as this is the cumulative event density across stages. Now it makes much more sense, and this also helps users to get a better overview about how the microseismic event density accumulate across different stages. What I just mentioned and demoed are the new feature and improvements in the generation and visualization of 4D microseismic volume. Now I want to introduce some new workflows we've developed for microseismic related functions in 8.6. The first workflow is calculating geobodies and SRV from in-stage 4D microseismic volumes and build deep learning model for predicting SRV from completion data. The simulated reservoir volume estimated from the microseismic volume can be used as an input parameter for well performance. We add an SRV spreadsheet to summarize the SRV for 4D microseismic volumes. SRV is a function of completion data time, so we can build deep learning model to analyze their relationship and find if any completion data are strongly related to the SRV. Let's go over this workflow in the software. So as you can see here, I created the 4D microseismic volume for the well, and I also created the SRV for the well. And the SRV can be estimated if you check the create geobodies for SRV estimation when you create the 4D microseismic volume. So it's in the user interface when you generate the 4D microseismic volume from the microseismic events. You can see here, we have a checkbox for creating geobodies for SRV estimation. So if this is checked, then the SRV will be estimated. And here, if you right-click the SRV folder, we add this SRV spreadsheet to summarize the calculated SRV. So it has different spreadsheet. The SRV per stage calculates the total SRV for each stage, as you can see here. And the interval SRV calculates the SRV in each interval. For example, in this case, is 10 minutes. And this accumulative interval SRV in stage calculates the cumulative SRV in each interval, but it's accumulated within each stage. And we also have this accumulative interval SRV across stages. And this calculates the accumulative SRV across different stages. So basically, the SRV value would accumulate from the first stage until the last stage. And also in this spreadsheet, we have the completion data calculated. You can see we have the average completion data calculated and also the accumulative completion data calculated. And this estimated SRV is also listed under the microseismic event. As you can see, it's listed here. So if you want to analyze the relationship between SRV and completion data, you can build deep learning model from here. For example, the SRV per stage. You can right-click and select Build Deep Learning Model. So in this case, the target would be the SRV, and the input attributes will be the completion data. If you think there are some completion data that may have relationship to the SRV, you can select those as the input attributes, or you can use our correlation coefficient ranking functions to rank the completion data that has a higher correlation with the SRV. And this next page of setting deep learning parameters is the same as other deep learning model, deep learning workflow, so I will not spend time explaining this. And if you click OK, it will generate the deep learning model. Then you can right-click on the deep learning model to do a performance analysis to review the model. So in the performance analysis window, you can see the correlation between the prediction and the ground truth, and the importance indicates which completion data is more important to the prediction of SRV. And the PD and the SAE also, this plots estimate how each completion data would affect the prediction of SRV. So this workflow of predicting SRV from completion data can help engineers to understand how the completion data would affect the microseismic events and which completion parameters are important than others. Next workflow about microseismic function is to make 3D volumes from microseismic events and predict microseismic event density from seismic attributes. And I will also demo this workflow in the software. So for this workflow, the first thing is to make 3D microseismic volume from the microseismic events. So you can see here, this is a new command to make 3D microseismic volume. And this is different from 4D microseismic volume because the 3D volume does not consider the time. The interface is very similar to 4D microseismic volume generation. And you can select an existing 3D survey as the geometry. So if you have 3D seismic survey, you can select that. And then the geometry would be constrained by the one you selected. Then the 3D microseismic event density will be listed under the selected 3D seismic survey. And the next page, this is the outlier filter to filter out some anomalous data. For example, I can use the amplitude, and any data larger than this value would not participate in the 3D microseismic volume generation. And in the next page, you can select any microseismic attributes to create a 3D volume for them. And this last page is for creating some different, is that you have some different 3D seismic and you want to extract to the current 3D seismic survey, then you can select those. Then you can click OK, then it will generate the 3D event density volume. And also the distance to well will be created. And this is a new attribute which you can calculate manually as well. If you right-click on one of the volume and select Calculate Attributes, and then you can select Calculate Distance to Well. And you can select one well from the tree view, then click OK, then it will generate the distance to well. So let me show you the results here. So this shows the 3D event density volume for well A, which I created. And this is just a one depth slice. And this is the distance to well. You can see here is closer to the well bore, while this here is far away from the well bore. So the purpose of this workflow is to predict the event density from seismic attributes. So, and this workflow can be done on interval, horizon, and stratigrade. So the second thing you need to do is to create an interval or stratigrade. And I will use an interval as an example in this demo. So I already created an interval. So this is what I created. I use these two horizons to create the interval. And this interval includes the horizontal well path for well A and also the microseismic events. Then on this interval, you can calculate the interval attributes. If you right-click and select Calculate Interval Attributes, then you can extract those 3D volumes and seismic attributes to this interval. For example, some post-stack amplitude, some inversion volumes, and the event density is the target attribute, so that should be extracted, as we will use this interval as a training data. And the distance to well is also another important input attribute to predict the event density. Usually, this distance to well will have a higher linear correlation with the microseismic event density than other seismic attributes. So we can select that. And then in next page, you can select one of the method to calculate the interval attributes, and I selected the RMS amplitude. Then you can click OK to generate. And these are the results here. Then you can start to build the deep learning model on this interval. So in this case, the target would be the event density. So you can right click on the event density and select the build deep learning model. And here, this is a target event density. And for the input attributes, you can select using our correlation coefficient ranking function. And the first one is the predicted event density, which would be excluded in the input attributes. So the first one is the distance to well, which has a higher correlation with the event density. And you can also select some other seismic attributes and the inertial volumes as well. Then this page is the same as other deep learning workflow. Then you can click OK. Then it will generate the deep learning model, and it will be saved under the deep learning models folder under the 3D intervals. And these are what I created. Then you can right click to do a performance analysis to see the results. So here is the cross plot. You can see the correlation is pretty good in the training, validation, and testing data. And also in importance, you can see which attribute is more important to the prediction of event density. And the PD and SE plot shows how each attribute affect the event density. And you can see here, this plot is the distance to well. So as the distance to well increases, the event density decreases. And this is a common phenomenon that we observe in almost all the cases. So after you review the model, you can predict the event density for other wells. And for other wells, you need to calculate its distance to well. You can create another interval, or you can just calculate it on the same interval. And here I created another interval and extract the same input attributes as used in the training, and also I calculated the distance to well. So you can right click on the deep learning model and then click predict property map. And then in this page, you can limit the output range. And this is the training interval, which I used a well A for training. And this event density is the target. And these are the input attributes. So you need to select the predicting interval. Then you can click OK to generate the event density map. And this is the results here. And I can show you the results. So you can see here, this is actually the predicted event density on the same interval used in training, which is well A. So, and this is the ground truth that we used for training. And of course, the prediction would be good because this is used for training. But let me show you the results on the other well, which was not participated in the training. So here, so this is the results. And you can see at the left, this is a predicted event density on another well B, and on the right, this is the ground truth, because we know the event density on well B, and I calculated the event density on well B to compare it with the predicted. So you can see they are slightly different, but it shares the same trends. As here, you can see the event density becomes weaker, and in the predicted event density here is weaker too. So this workflow can also be done on stratigrade. As you can see here, this is the results of predicted 3D microseismic density on stratigrade, and on the left is the ground truth. At the right is the predicted results. And this is in 3D view, and this is the section view for the prediction on stratigrade. So the benefit of this workflow done on stratigrade is that you can see the predicted event density by strata slices through it, and you can also see it on the section view. So this workflow could also be useful when users to predict how the event density look like by proposing a horizontal well path. You can use the well digitizing tool in AttributeStudio to digitize a proposed well path and apply this workflow to predict the event density on that proposed proposed well. And this workflow can be used to predict the wells in the same path or in other paths if they share the same geological settings. And we believe the workflow of predicting macroseismic event density from surface seismic attributes and the workflow of predicting SRV from completion data allow geoscientists and completion engineer work in an integrated and predictive manner. So the next function related to microseismic part is we add a new window to visualize multiple completion data. This is called completion data window. Let's see this in the software. So you can enable the you can open the completion data window using this button here. And then in this window, you can select the completion data to visualize. You can select multiple completion data. And in this window, the x-axis indicates the time, while y-axis indicates the completion data value. And you can manually adjust the axis range by dragging the x or y-axis. Or you can do it through the properties page. If you double click on the blank area, and you can change the display min and max for x and y axis in the visualization. And you can also change pump data line properties. If you double click on the completion data log, and in the properties page, you can change the color, the size, and the style for the line and point. So this is about this new window. So what I just demoed are some most important features we've developed related to the microseismic function in 8.6. Now this is the last important change I want to demo today, and it's about projection system. And since 8.6, we've changed it to a new projection toolkit called Project Software and improved the user interface to include a dynamic search function for projection system selection. And let me demo this in the software. So to change the projection, go to the File and Project Properties. And in the projection, you can uncheck this and select Set Projection. So this is the new interface, and you can see this lists the frequently used coordinate reference systems, and this are the frequently used projection for Canada and the US. So you can quickly find the projection you want. Or if you want to find more projections other than this, you can select this More button, and then it will open another list called Prefined Coordinate Reference Systems. So this includes all the projections, and you can find the one you want from here, or you can use this search feature. You can type some keywords And then you can see those two lists will dynamically changes. And then you can select the one you want and click OK. Then the next time when you set projection, the one you have selected will be listed under the frequently used projection list. So this is a very useful and convenient interface that we improved. So this is the end of my presentation. Thanks everyone for watching, and we will soon announce the official release of AttributeStudio 8.6. Please stay tuned. If you have any questions, please send email to support@geomodeling.com. And if you have any questions, I can answer it now.